All right, so last Wednesday we went through disk method. Disk method, you had the formula, the volume is equal to, it was pi. We integrated from some A value to some B value, and then it was the radius squared. Okay, and if it's in terms of x, it's the radius in terms of x. If it's y, then these guys would be y's in your problem. So if you look at number 2, this was the problem that you had. They gave you the diagram. They said y is 4 minus x squared. That's this curve. Okay, they give you the shaded region. We want to integrate from 0 to 2. They gave you that sample rectangle, and they said we're going to rotate this thing around the x-axis there. So in order to find that volume of that solid that's formed by that, I need to figure out what the radius is. The radius is the height for this rectangle. So the height of that rectangle changes when it's inside this shaded region. At some point, it's all the way up here. It has a height of 4. And then as I move to the right here, it gets a height that's really close to 0. So that changes, and it changes and follows the curve 4 minus x squared. So that's the radius at any particular disk that I'm looking at there. So that's my radius. So if I plug that into my volume formula, 4 minus x squared dx, the bounds for integration, think about this rectangle. It can go all the way over here to the left, all the way here to the right. From what x value to what x value does that rectangle range? 0 to 2, right? If it goes all the way to the left, it would be at 0. If it goes all the way to the right, it's at 2. So it ranges from 0 to 2. Right, now I need to integrate this. How am I going to integrate this? Yeah, let's multiply it out, square it. So you'd have 4 squared 16. Outer and inner would give you minus 8x squared, good. And then last times last would give me, perfect. Right, and now you can go ahead and do your power rule. We get 16x, 8x cubed over 3, good. 5th over 5, awesome. Right, and we're integrating from 0 to 2. You can use your calculator, plugging your upper bound, your lower bound. You're going to have to help me. I don't know what these numbers are. So if I plug in 2, I have 32. 2 cubed is 8 times 8 be 64 thirds. And 2 to the 5th over 5, 32 fifths. Leave the pi out in front. You can do this with your calculator. I'll refresh your memory how to put this stuff in the calculator as well. So 32 minus the 64 thirds plus the 32 fifths. Make sure when you put these fractions in, they're in parentheses. Do it with your calculator right now. 3 calculators up here if you need to borrow one. What's that? Is this your whole birthday week? Are you getting this calculator? No, it's here. I got more. This was your homework from last Wednesday. Okay. So it was, yeah, I don't know what page. 465, same as tonight's page. All right, so this was number 2. Anybody else put this in the calculator? See if it's just 6 pi over 15. If not, you can do the next one. All right. So we got the volume for this one. So disk method. What happens with your disk method when you draw this rectangle? The rectangle is going to touch the axis of rotation. If you look at this problem, the axis of rotation is the x-axis. The bottom of the rectangle is touching the axis of rotation. Today we're going to look at washer method, and that rectangle isn't going to touch that. You're going to have some space in there, and that's the difference between disk and washer method. We'll look at that formula. All right, let's look at number 7 from that homework assignment from last Wednesday. So this one is y equals x squared, right? Got the shaded region. It goes all the way up here to 4, stops at the y-axis, and now it's being rotated around the y-axis there. So which variable am I going to work with? Look at the last problem. Going this way, it's x's, you got it. So this way the rectangle's horizontal. So now I'm working with y value. So that's some little y value that I'm looking at that with there. So my volume formula, oops, we still have pi out in front, goes from a to b, some a value, some b value. We'll figure out what that's going to be. But now my radius is in terms of y. So let's figure out what that's going to be. So my radius from the axis of rotation to the end of the rectangle there, we said what variables are we going to have? What variables am I going to be working with in the problem? Y's. So I want to say the end of this rectangle touches this curve right here. That curve is y equals x squared, but I want my variables to be y's, not x's. So I want it to be x equals. If I solve this for x equals, I get what? Square root of y. So my radius is square root of y. Okay, I don't need plus minus because when I rotate it around the y-axis, that half of the curve is going to be picked up when that is turned into a solid. Okay, so I just solve for the other variable because the rectangle's horizontal. I want all y's for my variables. All right, I'm working with y's for my variables. So look at that rectangle. The rectangle's going to move up and down this time since the rectangle's horizontal. How far down and how far up does the rectangle range? 0 to 4 this time. The x values go 0 to 2, but the y values go 0 to 2 since that rectangle's horizontal. All right, and then my formula is radius squared, so square root of y squared. Square root of y squared is just what? Y. Right, integrate y, we get y squared over 2. Going from 0 to 4, plug in 4. 4 squared 16. 16 over 2 is 8 pi. Right, lower bound 0 just gives you 0. So that was number 7 from those homework problems. The last one then that I want to look at is number 10. Right, number 10, somebody had this solid that they were creating. I don't know which one of you had this one. It was sort of weird shaped here. It's kind of a parabola on its side, and it was chopped off here at 1. So this is my curve. X equals negative y squared plus 4y. The rectangle's horizontal, so what variables am I working with, x or y? Y's, right? Horizontal's going to be some y value there. And then, so let's set this up. So volume is pi. What does y range from and to? 1 to 4. And my radius, the end of the rectangle, this end minus this end is going to be that curve, negative y squared plus 4y. Other end of the rectangle touches the axis of rotation, which is 0. So my radius is negative y squared plus 4y. What am I going to do? Integrate, and to integrate, maybe I want to do square it. Yeah, let's square it, and then we can integrate by power rule. So y to the 4th, good. 8y cubed, good. And then 4 times 4 by 4y, 16y squared. Y. Great, and then we can do power rule. Y to the 4th becomes, oops, not a integral. Hold on. There, here we go. Y to the 5th over 5. Good. You got it. All right, and then you can plug this into your calculator. You're going to help me out. 4 to the 5th power, is that 1024 over 5? I think it is. 4 to the 4th power, and then times 2. I think that one's 512. Do it for me and check, make sure I'm not screwing this up. And then 4 cubed times 16. I think that one's 1024 over 3. Our lower bound is 1 this time, though, so I got to plug this value in. So I'm going to plug 1 into each of those, so this one's not so bad. 1/5 minus 2 plus 16/3. All right, with your calculator, plug this all in here. What did you get?
Like in terms of
Yeah, let's do an exact value for this, and then we'll put the pi with the answer. 154 over 5. All right, somebody else do it. Check to make sure that Kelsey has this right. Did it work out? Everybody else get the same answer? If you don't check it, we got to follow Kelsey blindly.
I got 153.
153 pi? Someone else got to try it. Math by majority.
Was it
153? Okay. All right. So we decided it's 153. All right. Now we're going to do this with the calculator because I want to refresh your memory how to do this. You can come up with the exact value with the calculator as well as a decimal estimate. So you might as well. So let's make this one right too. You might as well know how to do this with the calculator. So in your calculator, let's put this in y equals. Now this is FOIL, the second value that we had here. Shrink this up again. I could type this in this way as well too. I could go back to this original one up here if I wanted to. I just wrote down the FOIL factored out version there. All right. We'll use x. Yep. Okay, because your calculator is only set up to graph y equals, and then x is our variables. We can't use the y's. So leave it the way it is there. We're going to put this in, so it'll be x to the 4th minus 8x cubed. Crap. Try it again. X to the 4th minus 8x cubed, and then plus 16y squared. All right, we'll have to use x for that. Now you got to make sure that your window, when you put this integration in your calculator, it has to include these bounds. So my x values have to go at least from 1 to 4. It can be bigger than that. It can't be smaller than that, or it's going to give me an error that the window's not big enough. So mine's going from -5 to 5. That's fine. Second and calculate, which is the trace button. We want to integrate, which is number 7. Are you guys with me? Are you with me? You want to practice typing this in your calculator because this will save you lots of time and energy here. Now the graph that you're looking at is not the graph that we went through and we drew on that, that first page there. The graph that we're looking at is going to be the graph for this thing right here. All right, this is locked up. What's going on with this thing? X to the 4th minus 8y cubed x squared. All right. All right, I just changed my window a little bit. It wasn't letting me graph that. So I want to integrate this. My lower limit is 1. My upper limit is 4. Okay, it shades in the area there. It gives me this 30.6. If I don't know what 30.6 is, it's a fraction. You can go right from this screen and have it converted to a fraction. Are you guys with me? Okay, so if you're right here, if you haven't touched anything else on your calculator, you can hit the math button and then the fraction, and it will take the last thing that it came up with as an answer, which was that 30.6, and it's going to convert it into a fraction of, look at that, 153 over 5. What didn't it do? It didn't multiply by the pi because I didn't put that into the equation, so just put pi with the answer. Okay? If you want a decimal for this, we would take this number and do what with it? Yeah, we can go back and do decimal and put the pi with the answer, or I'm saying multiply it by pi and everything. So 153 over 5 times the pi, and then that's a decimal estimate for that volume, 96.133. Okay, so you can use your calculator to come up with those values. It'll help you when some of the integration is either too complicated or it's too much work to go through and do that. On your quiz on Friday, you have 5 multiple choice questions. For those problems, the diagrams are all drawn for you. The points of intersection are labeled. There's, I think, one I forgot to put the points of intersection on, but you'll be able to see what the points of intersection are because they're right on the grid lines there. So you'll know what the point of intersections are. So for those problems, you can do them right with the calculator. You can set up the integral, and if the directions are calculate, you can come up with this value. You know how to come up with the exact value using the fraction button on the calculator and put pi with your answer. Or you can come up with the decimal value and make your multiple choice match up. Not all of the multiple choice will come up with this final answer for the volume. Some of them I'll just say set up the integral, and I'm looking for either this or for this. Okay, how do you set that up correctly? All right. There's 2 open-ended questions on the quiz, and that you're going to go through like we did here, where you're going to draw the diagram, you're going to set up the integral, and then you're going to calculate the volume. And the calculate the volume part you can do with the calculator as well, but you'll still have to set up the integral and do the graph. Okay? All right, let's look at the notes then. Do you guys have your purple books with you? Awesome. Need your purple book? You're looking for 7.2. You're looking for washer. All right, so what we're going to do, just reset these here so you can kind of see. So we're going to go through and we're going to find volumes of washers. So at disk, what's going to happen is this rectangle is going to touch the axis of revolution. This isn't in your notes, it's just a little simulation real quick. So a washer, you're going to have space between the end of the rectangle and the axis of rotation. So if I take that rectangle and rotate that around, what do you notice that you have with this one that you didn't have with the other one? You have a hole in the middle there, right? It's like a donut. So this is like not the donuts with the cream in the middle, the donuts that have the hole in the middle there. All right? So you got that space in the middle there. You can look at what that set of points looks like there. So these are all of the rectangles. As they rotate around there, we're going to find the volume of these washers. Now, you did stuff like this back in geometry. Let me look at this one here. Let's look at this and then we'll talk about geometry. So this is the same idea. Here's my axis of revolution. We looked at this simulation and we had the axis of revolution be the x-axis for this one. Now if I take this rectangle, rotate it around that axis of revolution down here, you can see again, this will be all these washers stacked up. And you can see that hole going down the center there of that one. Okay, and I could do this with a whole bunch of other washers. Okay, so we have a whole bunch of them all stacked up there. So I'm going to have something that looks like this, right? And back in geometry, you found maybe the area of this. And you looked at a big radius, and you looked at a small radius, and to find the area, do you remember what you did? Big radius, right, minus the small radius. Okay, and if you were finding area, you did something like, pi big R squared and pi little r squared. You found the area of that piece that was left. So we're going to do the same thing. It's going to be a big radius squared and a small radius squared. Okay, get out of that. All right, so in your notes, we're down here at washer method. Okay, and this is what we just talked about. The rectangle in that shaded region. This one's got space between the end of the rectangle and the axis of rotation. If I rotate this rectangle around, there's one of those representative washers, and the washer has a hole in the middle. So this is what we just said. It's going to be the big radius squared times pi minus the little radius squared times pi. Remember, this little w here is just the width of each of these discs, and we said we're going to make that width really small so that when we stack all of those washers up, we get an exact value, and that's the integration part. All right, so let's go through. We'll set this problem up here, and I think I'm going to throw another one in here. We'll make something up. So I have these curves. So this would be like the last two problems that I was telling you about on the quiz. You have an open-ended one. So this we have to do everything. The graph's not given to us. We have to set this all up and then integrate. And then I'll show you where you can put this in your calculator. All right, so let's go through and set this up. So I have y equals 2. So I have, let me darken my axes here. Right, so if y equals 2, that's going to be up here. And then I have the curve y equals 4 minus x squared over 2. You can do this with your calculator. So it's up 4. And then if I pick two x values, I'm going to pick positive 2 and negative 2. If I plug in 2, 2 squared is 4. 4 over 2 is 2. 4 minus 2 is 2. So it's going to intersect here, and it's going to do the same thing at negative 2. So if I draw that parabola that opens downward, that's what I'm looking at. Can you see the region where they intersect? That piece right there is the region where those two curves intersect. So that's what I want to come up with. What's the area where those things intersect? And then they say rotate this around the x-axis. So I'm going to draw that little curly arrow there to show me my axis of rotation. So which direction is the rectangle going to have to go if this is my diagram? Show me with your hand, this way or this way? Why do you say this way? You are right. The rectangle has to be perpendicular to the axis of rotation. So it's a vertical rectangle this time. We'll do ones that are horizontal or parallel to the axis of rotation later. That's another method. So I have two radii for this then. This is my axis of rotation. The end of the rectangle that's furthest from the axis of rotation is going to be my big radius. The end of the rectangle that's closest to my axis of rotation is going to be my little radius. Think of the donut problem. What's the biggest part? What's the smallest part? So my volume using washer method is my big radius squared minus my little radius squared. So let's come up with an equation, because this radius, wherever this rectangle happens to be in this shaded region here, it's going to get bigger and smaller. So it's not the same. I can't use a number for that. I need a variable. I need the equation that follows this curve here. equation follows that curve. You got it. So that's my big radius squared. My little radius squared is this bottom line here to my axis of rotation. What's the space in there? That space stays the same. It is 2, right? 2 minus 0 or 2. So my little radius is 2. I need the bounds for integration for this too. So my rectangle can go how far to the left and how far to the right? Negative 2 to 2. Now I can keep it from negative 2 to 2, or if you look at that graph, what do you think you know about that graph between negative 2 and positive 2? Cut it in half? So I can integrate from what to what? 0 to 2, but if I integrate just this piece on the right, what do I have to do to get the actual volume? Double it. So I can make it a 2 pi. Why would I want to bother to do that? It's easier to plug 0 in exactly for your bounds than it is to plug in some other value. You don't have to, especially if you're going to use the calculator. Doesn't matter if you plug in negative 2 for your lower limit or 0 for your lower limit. It's still going to give you that same value. All right, so I'm going to leave it this way since we said to do that. I'm just going to make this 2 squared into 4. Now I told you we can use the calculator for this. So I'm going to leave it like that. Instead of multiplying that out, instead of foiling that, multiplying that binomial, I'm just going to leave it that way. The only thing is I have to be careful when I type x squared over 2 on my calculator, what do I need? Yeah, just put parentheses around that. So let's put this in the calculator. I'm going to write it on the side because when I pop my calculator up, oh, you know what I can do? I'll make it small. Hold on. All right, so in your y equals, type this equation in. Don't worry about 2 pi. We'll multiply the answer by 2 pi. So in my y equals, I need to clear out this junk. You guys doing this with me? All right, and then just look and make sure that you have it typed in correctly there. I need this binomial squared, parentheses around that x squared over 2, or if you don't want to type it in as x squared over 2, make it 0.5 x squared. It's the same thing. All right, and then the minus 4 on the end. I got to make sure that my bounds for integration are included in my window. So once you have it typed in there, hit your window. Make sure your window at least goes from 0 to 2. It can be bigger than that, can't be smaller than that. So back at y equals, are you guys with me? Typing this in. Let's do it. Second calculate number 7. 0 to 2. We get 14.933. I don't want that decimal, I want a fraction. Yeah, mine has a newer operating system, so it may look different from yours. And then multiply by 2 pi, and we get what? Times the 2 pi, yeah, because remember we changed it from 0 to 2. 448 pi over 15? Is this working for you, yes or no?
Yes.
Okay? You said no? Okay. Yes. Yes, that's what I'm trying to do. Yeah, the only thing that you won't be able to do is if the direct, you need to close a parentheses between the square and that. Before the square. Right there is where you need it. Yeah. This is for the fraction, that one, and that's for the first quantity square. Yeah, I think you're good. Yes, you can put them all in there. The only thing you won't be able to do is if the directions say set up the integral, you got to do the setup for it. But you got to do the setup to put it in the calculator anyway. Okay? Are you guys all with me? Yeah, grab the pencil. All right, so yes, you can do these all with the calculator. I know you know how to integrate. That's what we've been doing all year. Okay, so put these in the calculator. I'm letting you use it, being able to use it. It's good stuff. All right, let's do one more. Let's do one more of these type. Let's see. So this is a bonus one. You're just gonna have to write this into your notes. Let's do. I remember something off the top of my head. No, let's do it this way. All right, so this is what we're going to do. X equals y to the 2/3. And I'm only going from x equals 0, which is the y-axis, y equals 1. So let's plug in. If y is 1, what's 1 to the 2/3 power going to be? 1. So it's kind of looking like that. And then it says y equals 1, which is a horizontal line, x equals 0, which is the y-axis. So I'm looking at this shape right here. That's my shaded region. And let's rotate this around the x-axis. Okay, so you're going to have a space. Draw the rectangle in there. Which way does the rectangle have to go if I'm going around the x-axis? Show me with your hand. Going around the x-axis, which way does the rectangle have to go? Has to go up and down. See, I tried to trick you by making it x equals y to the 2/3. Your rectangle's always perpendicular to the axis of rotation. I'm sorry. And it's on tape now, too. All right, so it's perpendicular to the axis of rotation. So we have a big radius, we have a small radius. Since my rectangle's up and down, the width of the rectangle is some x value, so I need my equations with x's, not with y's. So what do I need to do to this guy? X equals y to the 2/3 power. I need it to be? How about I need it to be y equals 3/2? So y equals x to the 3/2 power. It's not inverse. We're just solving for the other variable. Okay? Just solving for the other variable. Eventually you would shout out the right thing. All right, so now my big radius, top of the rectangle to the axis of rotation. What's this height here? 1. My little radius is the bottom of the rectangle to the axis of rotation. The bottom of the rectangle touches this curve. What curve is this? What curve is this? X equals y to the 2/3, or the other direction because I want it to be x's instead of y's? To the 3/2, thank you. All right, so my volume is pi big radius squared minus my little radius squared. X goes from what to what? 0 to what? To 1. All right? Big radius squared would be 1 squared. Little radius squared would be x to the 3/2 squared. 3/2 squared is going to give you what? You got it. All right, let's be wild and crazy. We're going to do this one by hand. You ready? Integrate 1. 1x, that's right. X to the 3rd is? Fantastic. From 0 to 1. Plug in that upper bound, we have 1. 1/4. You got it. Plug in 0. You get 0 for those. So we get 3/4 pi. Right? You don't have to do it, with your calculator. If it's something like that, it probably would take you longer to type it in the calculator than it would be to integrate it by hand. But you don't have to. You do them all with the calculator. Right? Is this bringing back all sorts of warm, fuzzy memories for you from last week? Disk method, washer method. What's the difference between disk and washer? The hole in the middle. You have a little radius with the washer method. You have a big radius, a little radius. Disk method, the rectangle is going to do what with the axis rotation?
Rotate around the axis.
The rectangle and the axis of rotation, if it's disk method, the axis of the rotation and the rectangle touch each other, right? If you look back at this one, rectangle touches the axis of rotation. This one, the rectangle touches the axis of rotation. This one, the rectangle touches the axis of rotation. If you go back to washer method, you go to washer method, you got space between the rectangle and the axis of rotation. That's the difference between the two of them. Alrighty, homework problems back there, 5 and 6, they give you the diagram, so you don't have to redraw it. I prefer to redraw it, so I have it right there with my homework. The rest of the problems, 13A, 14A, the rest of them, you need to draw a diagram, draw your sample rectangle, put the little arrow so you know where you're rotating it, and then do your integration. You can do the integration part with the calculator, but I need to see the setup and then your answer there, okay? Alrighty, let me pop these up here. Let me stop this first here.